Good afternoon, everyone. Today, we talk about the roof. So we're gonna see the roof construction method and detail assemblage and the different material type for designing the roof. So we're also looking at these types of the green roof design. It is Academy of Science building designed by Lorenzo Piano. What is about the advantage of the green roof? What about the disadvantage? And what about the assemblage method? So we're looking at the different aspect of the designing the roof and the construction method and detail the design. The roof is facade, the most exposed to the weather. So you can just consider the roof is the facade most exposed to the weather. It is always the locating on the top, and it means it's most exposed area to the weather. So it is exposed to the rain and direct sun every season. It means you have to be very careful to design your roof. When you design the roof, you should consider the weather. Let's think about the hat. It protects our body's uppermost part. In the winter season, we wear the stocking hat to keep warm, right? The stocking hat preserves heat from the body and protect cold air from outside. In the summertime, we wear the straw hat to ventilate with the outside and inside. It helps warm air out of your body and receive cool air from the outside. And also protect the direct sunlight from the sun. So this is a kind of basic concept of the roof. Your roof is like a hat. You have to be preserve thermal energy from inside, but you have to protect direct sunlight from the outside. You also consider about the ventilation too. So insulation on the roof is the same effect as the hat for your body. You can see insulation. So on the roof, hat for your building. You're keeping some thermal energy from the inside. To decide proper insulation type, you have to look at the climate zoning map. Okay, so you remember about this insulation zoning map from the last class. You just can understand where's Iowa. When your project building in Iowa, so northern Iowa it is the zoning 6, and southern Iowa it will be zoning 5. And you can simply just comparing to this map and this zoning table, you are easy to know about what is the minimum R value for your structure, for your roof structure. So from this one, you have to find the proper insulation type to design the roof assemblage. So we can talk about the different roof insulation type. The first one, cellulose fiber board. It is eco-friendly insulation material. It is also cheap. However, it is lower insulation efficiency. It is only 2.8 per inch. You remember about the EPS, XPS. It is about the 4 or 5 per inch R value, but compared to this one, it's very lower R value. The pellerite board, it is rigid insulation type made by the volcanic glass. It is great for the fire resistant. However, it is very low R value. This is also 2.8 per inch. Okay. And next one, cellular glass board. It is made by recycled glass powder. That's why it is good fire resistant material like the pellerite board, because it's also good fire resistant material. However, it is still very low R value. Okay, so we can jump into the rigid insulation, foam insulation. The first one, EPS. We already discussed about the EPS and XPS. What is the difference between the EPS? Less expensive than XPS insulation, with pretty good R value compared to the previous insulation. However, comparing to the XPS, it is still lower R value. Also, it is the greater moisture absorption than XPS. This is loss of the gap between the particle. It means the water is penetrating into that. You remember when water penetrating into the insulation, you losing the insulation performance. So from this reason, mostly we were considering about XPS, even it is a little more expensive than EPS. But this is a good R value here, and then it also the cross cell has compact particle structure. It means it resists the moisture and make a good R value. But it is combustible material also. It means it's the fire. So that's why you have to be considerate about the fire protection assemblage when you build require fire resistant. So next example is polyiso foam board. Always polyiso is very good R value. It also rigid foam type and face of aluminum foil, grass fiber mat, or cellulosic the mat to protect the fire. So it means this kind of the facing actually protect the fire. It is good R value. It's very good R value compared to the insulation. However, it is expensive and R value will decrease over the time. Okay, so you can just kind of choosing the proper the insulation type depending on the required the minimum R value from the project and from the project location. Also, you can consider about your budget, so you can choose the proper insulation for your loop design. So now we can talk about installation. So it is very similar as wall assemblage. Simply, wall assemblage is more like that, but it is simply rotating this and making out the loop. So you can see this is a structure part, right? It is called as the metal structure, or it can be wood structure. So now we just kind of want to discuss about this framed structure. And then remember that we can add in the insulation, right, inside. And then this is a finished ceiling. The wall in the wall assembly you can consider as the inside gypsum board, and the outside, which is exposed to exterior, you have the cover board and sheathing. But your loop design, it is required a substructure here, and to protect the substructure, you need the waterproofing membrane. Once again, so you need the framing for the wall, for the roof, and then you need the insulation, right? You have to be checking about the minimum R value for the project location, and then you need the ceiling finish, and then you need substructure. Usually we using the plywood, and to protect the substructure, you need waterproofing membrane over it. Okay, so this is atypical the loop assemblage. Okay, but when you're just having the rigid insulation outside, it works as well. So it means the finished ceiling material, and you can have in the framing. Even you can just add in the insulation here, and you can have a substructure. Okay, and in this case you can add in the vapor barrier outside, and you can add in the rigid insulation outside. Okay, and adding the waterproofing membrane to protect the insulation. So this one is kind of a atypical one. You can actually add in the insulation outside. You can actually protect the thermal transfer with this layer and this layer together. So just considering about the insulation outside, inside, it can be the better performance comparing to this one. Okay. So option 2 example here, you better understanding about this diagram. The first one, you need the substructure, which is you can see the substructure over your roof, and then you add in the primer for the vapor barrier here. Okay, and then you need the exterior rigid insulation outside, and to protect the insulation, you need the waterproof membrane. And here I just ask, you can do the roof finish. It is shows a cap sheet, but it is available to add the roof decking system, which is the wood or stone panel. But you can talk about the different the roof decking system later of the lecture. And you can also consider about the stone ballast, which is you can add in the stone over the waterproofing membrane. So we also talk about this type and this type later of this lecture. Okay, so when you're just understanding about the wall assemblage, which is manual wall assemblage, it is also very easy to understanding about the loop design, because it is very similar the layer and sequence as well as the wall design. So now we talk about the loop slope, which is the loop pitch here. How you can just calculate the loop slope ratio. So this is a calculation here. Loop pitch, the slope, the rise and span here. So means it is terminology here. This is a loop slope and it is called as rise and this is called as span. Okay. In from the here you can say this is a slope and this one you can call rise and this one you can call span. So just kind of understanding about the loop slope has the three different category. Number one, low slope and moderate slope and the high, which is a steep slope. The low slope, you can consider about the span is 12. Okay, everything is kind of fixed at 12 number. And then the low slope is 1, 2, 3, which is when you're having the 1 rise and a 12 slope, it can be low slope. It can be about the 3 rise, you can do the 3 here, and the 12 is fixed it, and you can do the this. But rise, if rise is more than 3, which is the 4 to 7, it can called as the moderate slope. Okay, so it means you can do the 8 is 8 here, this 4 and 8, and this is much sloper. Okay, and then high slope is steep slope. If rise is more than higher than 8, it is called as the steep slope. Okay, so depending on the rise and the span ratio, we can call it as the slope. It is can categorize. It can divide by low slope, moderate slope, and steep slope. Now we can considering about how you can design the flat loop. So this is all sloped loop here, right? But with how you can designing about the totally flat the loop design rather than these types of the gable loop. So even when you're designing about this flat loop, you should consider about the slope. Okay, is it usually asked to the 2% slope, but someone said 1% slope is okay, but I'm highly recommend the 2% slope because I just explained it a little bit later. So but how you actually making the 2% slope over the flat loop system? You can see this is a finished ceiling and the loop framing, and you can add in the insulation here, and this is a substructure, and you can make a 2% slope or 1% slope, the tapering the insulation. So it means you can actually drain out the water out of your loop. Even next example, you can actually make the sloped insulation over sloped substructure. You can simply shape the structure in here and here. In this case, you can actually make in the slope and the insulation just simply following the substructure, and then you can just getting out of the water as much as possible. So this is substructure, but this is another layer to making out the slope. So when you're just simply adding the flat slope, the flat loop, you can adding the decking system over this sloped loop area. What is the problem? If you don't have any slope over your loop, you just totally making the flat loop. What is about the problem over your flat loop? You can see this ponding issue. If your loop is truly flat, the major problem is ponding. It means water is impossible to get out of your loop. So it means if you have lots of water, lots of rain, the water keeps staying under your loop. So what is problem? Problem is making the loss of a waterproofing issue, which is it is damage to your waterproofing. It means this you can see the loss of a water issue in your home or your building. Also, you can see the structural failure because about this weight increasing. So you can consider that this is a live road, but when more water and more rain is coming down, this is getting heavier. So from this region, when you're having the structure, it actually impacts your structure. You can also have some making out some waterproofing issue. So from this region, I just ask you to provide 2% slope over this flat loop. So means when you see the outside, this is your design and making 2% here, 2% here, and outside you can simply the covering edge, right? So it means from the outside you can only see the flat loop, but inside of this cover edge you can having this actual the slope for the drainage of the water. So you can see the how you can actually designing about the drainage system. This is a higher, and then this is higher, and then you have the drainage system, the edge of the real roof, and you can also add in the loop drain in the center of your roof, so it is easy to get out of the water when you provide 2% slope. So from this kind of a calculation, now you can understanding about how you actually getting this thickness and how you actually calculating the roof condition. So this you can see the structure here, which is a substructure, and then you have to be understanding about what is about this height, and then just simply adding the roof finish, the decking thickness. So it means how you can just getting this A number. So you just kind of simply know about this your loop drainage system, and then this is the drainage, the flow here. So you can just simply calculating from here to here. You can just kind of measuring it. It is 120 inch, for example, but you can just kind of varies depending on your project. But you remember we need to be provide 2% slope. So means you can simply getting this calculation here. This is the 120 inch, right? But we have to be calculating A here, and now we understanding about that this is a 2%, right? So I mean how you can calculating here 120 and A, which is large, which is the 100% times 100, which is it is 2%. The problem of this calculation, A can be 2.4 inches. Okay, this 2.4 inches here, A is 2.4 inches, and plus this the deck thickness, which is you can calculating the actual required thickness over this substructure. Okay, so this is a kind of calculation you can find out. So we already know about A, and we already know about this number here, and we already know about the 2%. It is the roof slope requirement, and then basically from this calculation you can getting the A number, which is a 2.4 inch minimum. It means you can just get in the total roof assemblage, which is a 2.4 inch from here, and plus the deck, which is the option, and you can also add in the loop slab here. You can just adding it. So it means you can just get in the total number from here to here. Okay. So now you can see the to protect the ponding issue, roof need an internal drain system. So you can see that this is an internal drain detail. You need to be remember the waterproofing membrane has to wrap up the loop drainage system to protect water penetration. You can just kind of see your drainage system, and the waterproofing membrane actually protecting this corner to protecting the connecting condition. Okay, so this is one important part for understanding about this internal drain. And then let's watch the one of a video. This is showing the installation, the video, how the roof drain system that works in the loop condition. You can watching it together. And next video, I just kind of we watching these two videos together, and then I just kind of introducing about the Garbite, the loop drain system. Garbite is a manufacturer company, but you also kind of see how you understanding to making the common drain system for your design. Okay, so let's watch these two videos together, and then we talk about some next topic, right? So now we talk about the roof deck type. There's a two roof deck type, the non-nailable deck and nailable deck. The nailable deck is simply simple. You can just kind of overlapping two decking and then nailing together to holding the substructure system. But what about the non-nailable deck? It means they don't using the nail to holding each panel. They simply place each other, but adding this waterproofing membrane over it. But how you can holding this non-nailable deck safely? In this case, you might consider to use the ballast here. What is the ballast? Why do we need a ballast, which is a gable over the roof deck? It's used for the non-nailable deck. At the non-nailable deck, the crushed stone ballast helps the holding the roof system in place. You can just see this example. This one is the metal decking system, which is the structure, and then adding the insulation and waterproofing membrane. So non-nailable deck, you can adding the crushed stone, which is a ballast stone, to holding this non-nailable deck in a place. So you can also consider about the different the finish material to holding this non-nailable deck, which is a ballast, and also you can consider about the roof decking system or green. So you can these types about some finish material to holding this non-nailable deck in a place. But we can talk about the ballast, which you can use in the crushed stone. But some of our region is illegal to using the crushed stone ballast in this area, which is Florida here. This Florida has the strong wind, which is gable is able to break curtain wall by wind in the southern Florida area, which is a blue zone here. It's illegal to use in the roof ballast. So because you can see the window crush, the crushed stone, it can be affected this issue here. So let's talk about the green or the painted roof. What is green roof? The green roof definition, it is the roof of a building that is partially or completely covered with vegetation. It asks to include additional layers such as the waterproofing membrane, the root barrier, and the drainage and irrigation system to designing this green roof design. Okay, so looking at some about the benefit of the green and the painted roof. First one, what is the benefit of the green roof? The green roof reduces the heat island effect, which is the main cause of the ozone production. So you can just come by comparing the rural area and city. The city usually 3 to 10 the Celsius degree higher than rural area because about the heat island effect. So when you're having the heating from here, the water evaporating through this green area. From this region, rural area, usually the temperature is dropping down. However, in a city, this earth is covered by the concrete. From this region, the water is hard to get out and hard to evaporate from the earth. From this region, the concrete surface, the heating, then it means it can increase the temperature. So, but when you have your roof has the green space, it means you have a evaporation from the earth. So it means you can actually reduce this heat island effect. So you can see that your green roof can be the heat absorption and refraction. Okay, it works as the insulation. The water evaporation from the soil, which is the water evaporation from the soil, it can be reduce the temperature, and you can also reduce the heat transfer between outside and inside because it works as the insulation. Of course, you need another insulation, but it is also increase the insulation factors and act as the insulation for the building. You can reduce the heating and cooling demand for the space. So you can just kind of see this assemblage. I think that is very important to know about the green roof design because the people just kind of draw out sometimes designing the finish, the roof here, and then just kind of designing the green system here. But we actually, when you're designing the green roof, you have to have the roof drain, the layer for the design. So you can just kind of understanding about this system. This one is the substructure of your roof. And then you have to be in the waterproofing membrane and insulation. This is a very similar as the atypical the roof assemblage. However, to making out the green roof system, you have to add this roof drain layer, which is over the water, the insulation. You have to have waterproofing membrane. Okay, it's very typical the typical roof assemblage type. But over the waterproofing membrane, first you have to have the protective layer, and over the protective layer you have to have the drainage layer, and over the drainage layer you have to have the filter mat, and over the filter mat you can add the earth, okay, which is a growing media. Please remember about the loop drain, the sequence, the bottom of the earth, the media, you have to be having the filter mat, and the bottom of the filter mat you need to have a drainage layer and the protective layer, and the between space you have to be having the substructure and insulation and waterproofing membrane. So just kind of understanding about these sequence to understanding about the roof assemblage. So you can just see what is about the function for each one. The filter mat here, you can see the filter mat, below the growing media. It is locating between the growing media and the drainage system. It is to hold engineered soil in place and still to prevent the small media particle, and it helps to flow water from the vegetation layer. So we're gonna see the filter mat in the detail from the next slide. And drainage layer, you can see the drainage layer below the bottom of the filter mat. So every green roof must have a drainage layer to carry away the excess water, especially in a low slope roof. Okay, and then below the drainage layer, you need a protective layer. It can also called as the root barrier. It locating between the green roof assembly and the waterproofing system. It provides extra protection of the water penetration from the earth. Okay, so let's look at this example here. You can see the roof drain assemblage. You see here the green roof, which is the growing media, we can say. And now we talk about the filter mat here. What is about the filter mat here? This is a filter mat. So filter mat, the G is a filter mat. The filter mat, you can see that this is looks like this. Actually, this is a protect the small particle, and also this filter mat holding the growing media in a place. Okay, below this filter mat here, you have to have the drainage mat. Okay, drainage mat here. It's like a very dimple pattern, kind of the plastic layer. It is usually the collect water from the earth's media and the growing media through the filter mat, and then they just collect the water and then redirect the water, and then it's getting out of the water from the growing media. Okay, and then you need a protected layer, which is we can call as the root barrier. You can see the root barrier here. This is root barrier. It's located between the green roof assembly and waterproofing system. You can see the waterproofing system. It is the water protection from the earth. Okay, so just kind of understanding about these three layers one more time. I can erase everything. So first one, you have earth here. Okay, and then below earth you need a filter mat, which is this is a filter mat. So what is about the function of the filter mat? It holds engineered soil in place, and also it protects small media particle from the earth. And then you also need the drainage, the mat, which is like this pattern, the plastic, and it collects the water from the earth and then redirect water and get out of the water from the place. Okay. Next one, you need a protected layer, which is we can call root barrier. Which is you can root barrier locating between the waterproofing membrane and the drainage mat. So mean it is extra protection of water penetration from the earth. Okay, and then you need a waterproofing membrane, and insulation and the substructure here. Also, we can talk about what about earth depths, how you can deciding about earth depth, and how you can know about the required dimension, required depths for the growing media. So depending on the printing type, you can deciding about your depths. If you have a ultra extensive, which is the just glass here, you only need a 2.5 inch to the 4-inch media depths. But if you have the extensive, which is a small, the shrub here, it is usually required a 5-inch to 8-inch media depths. But if you have a lots of if you have some of a tree, small tree, and then some of a shrub, you need a more than 8-inch media depths. But you can see the specifically depending on the printing, it requires different depths of the earth. So you can just find the proper depth from the printing. Okay. Now let's watch this video. It is introducing about the Academy of Science loop garden system. You're just gonna understanding about what is about the benefit of the green roof system in the Academy of Science. Let's watch this video together, and then we talk about the walkable loop.
Take yourself across the seas to the Mediterranean subtropics, connected by pastel hills spotted with spiky plants. Perhaps a centuries-old oak tree like a wise mage claiming its semi-barren land. From the chaparrals of the west coast to the humid swamps of the south, landscapes essentially define the world. They speak to our very nature, the core of who we are. Landscapes are our home, our environment, our health, and at SWA, our passion. In San Francisco, a city defined by aspiration and diversity, lies a remarkable living work of art, an animate sculpture with a striking ability to evolve, driven and supported by nature alone. One that stems from a past life, offering new opportunities to flourish and thrive. As an homage to the 7 major hills in San Francisco, the living roof atop the California Academy of Sciences was rebuilt in 2008, replacing an outmoded and earthquake-damaged complex. Nearly the size of 2.5 football fields, the Academy wanted to develop a landscape substantial enough to impress its 1.6 million annual visitors, while having a fraction of the carbon footprint of most developed environments. The decision was to create the most inspiring landscape architecture project ever accomplished, situated right on top of its roof. SWA was up for the task, developing some of the most original and resourceful designs to date. Custom structural drainage systems were constructed to keep the soil from slipping down the steep hills. Patented biodegradable planter trays were used to reduce waste. More impressively, the entire roof is comprised of nearly 2 million plants native to the Bay Area. This living piece of art flourishes today, even inspiring an educational outreach program focused solely on the technology that went into its design. The green roof absorbs 3.5 million gallons of rain each year, reducing the amount of stormwater runoff by a stunning 98%. This environment has evolved into a habitat for a diverse amount of creatures, from local birds to insects, bringing to San Francisco what could have been lost by the very development that makes this city such a prolific aspect of the world's culture, transforming from a stagnant concrete structure to a living organic contribution to the city.
So now let's talk about the walkable loop. You can propose the walkable loop deck on your project. You see the stone paving here, and then wooden deck here from this project. So how you can design this walkable loop over this sloped loop location. Okay, so you can see the section here. You can see that this slope here. I just ask you to make a 2% slope recommendation, and then you making out this flat loop here, which is a flat decking system here. So you can actually using the adjustable pedestal here. Okay, so you can easy to change the height depending on the requirement. So from here and here, this location required more height. So from this region, you can just having the different combination to set some same height from here, from the slope. Then you can just making the flat loop here. So also you can just concentrate using the wood blocking. So means you having this wood is kind of easy to shape. So that's why to making this flat loop, you can shape the wood, the blocking, or you can just using this adjustable pedestal material. You can see the construction image. You see the pedestal, and then the install the wood decking, and also you can add in this stone paving, the decking over the pedestal. Okay. So now we discuss about the moderate slope. You remember the moderate slope. It is the 12 span, and then rise is 4 to 7. Okay. So you can just kind of understanding about the terminology. You can call the edge of the loop. You can call it as the eave, and then top of your loop. You can call it as the ridge. And then this slope you can call it as the gable, and then between the slope you can call it as the belly. Okay. For the moderate loop or steep loop, it probably requires the flashing, okay, at the loop edge, and this flashing the lap up the waterproofing membrane. You can see this edge and the waterproofing membrane lapping up to protecting this corner. What is about the gutter means, usually from the slope you can just kind of collect all water through this gutter, and then this gutter is flowing into the downspout, and then downspout is connect to the earth, and then also you can just connect to the public switch, and then it is getting out of the water from the loop. I mean, water is flowing down and then collecting it and redirect to the downspout, and downspout is connected to the earth, and then this one is connected to the public switch and get out of the place. But we don't like about the downspout a lot, because when you're having a downspout in your elevation, you probably doesn't like about these kind of extra pieces over the elevation design. So how architect considering about this downspout and gutter design their project? So this project is the Frank Lloyd Wright Buffalo, the masterpiece, the project. So you can see the gutter here. It seems like this is the downspout, but where is the actual downspout here? It seems like they don't have any downspout, but how they get out of the water from this gutter? Okay, so you have any guess? You can just gonna guess about some detail. The Frank Lloyd Wright actually designed this big water basin. So means you can see the downspout. Instead of the downspout, you can just kind of drop the water, and then this water basin, the collect water, and then this collect water is connected to the sewage system, and then it's just getting out of the water from the site. So this is we can call the catch basin, which is instead of doing this vertical downspout, they just kind of making the bigger the catch basin, and then just get out of the water from the gutter system. What about this building? It is Longchamp Church, designed by Le Corbusier. Where is the gutter? Where is the downspout here? So you can just connect here. The Le Corbusier designing the gutter system more sculptural wave. So means they just kind of design, and then you can see the huge sculptural scale, the water basin, catch basin, and then this simply just getting out of the water, and then this is collecting the water. Okay, so this is they using the system for the getting out of the water from the roof. But nowadays we can also recess the gutter and downspout in a contemporary architecture. To keep the pure form, architect tried to recess gutter and downspout in a roof assemblage. You can see from this detail, you can see the gutter here. Okay, you can see actually outside you can see this elevation, but you can hide and recess this gutter system into the wall assemblage. So you better understanding about this detail here. You can see the recessed the gutter system. This is showing the glass, but you can see the elevation here, the solid elevation. You can simply just consider as a solid elevation here to here. Okay, interior wall, and this is exterior wall, and then this gutter system totally recesses into the wall, and then this downspout also recesses into the exterior wall assemblage. Okay, so these two, the interior wall and exterior, the cladding, and you can actually recess the downspout and the gutter into the wall system from the roof. So let's talk about the high slope, the roof. High slope roof, you have a 12 the span and 8 or higher the rise. Okay, so it usually provides tensioning impact when you use the high slope roof. So you can just kind of having the same the terminology. It is called as the belly, it is called as the eave, it is called as the ridge, and it is called as gable. So just kind of looking at the some assemblage system here. The first one, you need the roof finish siding or any types of the roof material here. We talk about the roof material later of this lecture, and you need the underlayment, which is you can see number 2, which is waterproofing membrane here. Okay. Number 3 is the fascia. You just kind of protecting this gable part and structure. You need this face material, which is a fascia, to recess this structure system from the outside. And you need the insulation. Okay, so this is a very similar as the flat roof design. The next one, you need a roof substructure. You can see that this roof substructure. Next one, you have a eave panel. What is about the eave panel and venting system? So it doesn't have an eave panel venting system flat roof, but you can also see the roof eave system at the high slope or moderate slope condition. What is about the function of eave panel and vent? So you can just kind of better to understanding about this. So you can see usually the parking garage in your apartment, you can probably see the perforated panel. So what is about the function of this one? So you usually ventilating the air through the moderate and high slope roof. So you can just also see the ridge here. I think you better to understanding from here. The ridge also having a little bit gap between, and you can see some venting here. So means the air actually flowing from the eave and through the roof assemblage, and then it's getting out of the roof ridge system. So means this is a keep ventilating air. Even water is inside here. It is easy to dry it out because of this ventilation from the eave panel to the roof ridge here. Okay, so that's why you can providing the ventilation space for the eave panel vent at the bottom of the roof, and then you need to have the ridge ventilation here. So it means air actually flowing from the bottom to top to get out of the water and dry out the water from the system. So now we discuss about roof finish material. Okay, first one, the most common roof material is the zinc and aluminum zinc. The zinc is the most popular roof finish material. It is long-lasting finish material. It also protects weather very well. You can see that this project here, this Albany Entertainment Center, you see that this is the zinc and aluminum zinc, the material. So there's a lot of different colors available. You can see this color option here, and you can just kind of find out the finishing material using the zinc and aluminum zinc. This is another the project. So you can see using the zinc and aluminum zinc at the roof. But when you see this roof condition and zinc and aluminum zinc, it usually having some standing shim. This is, you can see the shim here, which is you can call the standing shim. And also you can find out the standing shim here. What is about the standing shim? Why we need a standing shim for zinc and aluminum zinc? Because you have to be connecting the zinc panel together. So you can see this example. You have a first zinc panel, and then this is a next panel. To overlap two zinc panel together, you put the panel together, and it needs to cross one side. You can see simply they overlapping the two panel together, and then it crossing this panel here. You can just make that out, and then rolling the foam, standing the shim panel. So just kind of the rolling it and then rolling down to making this standing shim. So to making under this standing shim is easy to connect from this 1 inch to 1.5 inch the clip system over the roof, and then it's very well tightly connecting from this clip system over the substructure to this zinc and aluminum zinc the panel. Now we talk about the shingle. So next material is roof shingle. It consists of an individual overlapping element. These elements are typically the flat and rectangular shape. The shingle are made of various materials such as wood, slate, and flagstone, the fiber cement, metal, and some plastic. So you can see that this asphalt shingle is a cheap and most economic the shingle type. It is asphalt shingle. It is available lots of different color, and it's pretty good. The performance, however, it looks like a little bit cheap looking kind of mid material still. So you can also see that the ventilation system here, the eave panel, the ventilating out, and then you can see the top, the ventilating out of the ridge. So this is a pretty good water protection. Also, it is breathable part using the ridge, the panel for the ventilation. So you can just kind of also consider about the slate, which is a slate shingle or wood shingle. You can have a lot of different shingle type you might consider for your design. So next one, you can think about the fiber cement shingle. The fiber cement shingle is also very popular in these days. It has the various color option. Also, it has the various texture. Sometimes it looks like wood, the timber finish texture. Sometimes it looks like a concrete finish looking, or sometimes you can use in the matte finish. Also, sometimes you can the shiny finish. So there's a lot of different option to using for the roof, and also the James Hardy siding product you can also using for the wall. So also it is very good performance, and it's protect the weather very well. So from this reason, the fiber cement shingle is pretty popular to using for roof and the wall as well. Next one is zinc, aluminum zinc shingle. It is kind of zinc shingle panel. It's very similar as the zinc and aluminum zinc type. It is different colors available, and also it is simply the overlapping each panel to panel. You can see the first panel, and then this is second panel, and then they have to be nailing down and protecting this corner, because they have to be overlapping each other to protecting the water penetration through. So without this, if you have separating, water is very easy to coming in, and also it is exposed to the nail hole. So that's why you're just making out the nail hole here to hold in this shingle, and then another shingle have to be overlapping and protecting this nail hole location. Okay. So next shingle type is the ceramic shingle. Usually you can find the ceramic shingle from the old building, which is a historical building. Okay, it's pretty beautiful, kind of finished out. Okay. So also you can just kind of find out the contemporary shingle type. I just kind of upload this video on the canvas. Please watch yourself and then understanding about what kind of shingle you can use, right? So this is kind of better to understanding about the materiality about the shingle for your roof. So next one you can considering about the corrugated panel. So this corrugated panel is possible. The option is the stainless steel, aluminum, titanium, copper, and zinc, aluminum, zinc. It is all good weather resistant material. It is delivery the visual delight because having some articulating some actual the panel. So there's some different articulation type. You can see the board lip, which is the bottom part is the wider, and the V beam, you can see the V shape, and the box beam, you can see the very similar kind of size and bottom and top, and the corrugated is more wavy pattern. It also having the lots of different color option here, and then you can also choosing the proper the corrugated type, and then combining these two together to making out your own corrugated panel. So you can just have here, I think that is kind of, you can see the body color tip from the building, and then using the charcoal black color, and it is pretty contemporary looking building, even they using this corrugated panel. Also you can see the cement panel. It is also popular because it looks like a cement, which is a concrete panel. It is composite material having the very light weight. Sometimes concrete panel is much heavier, but they actually making by the looks like concrete made by the composite the material. It is assembled by the rain screen system. It means the cladding system. You remember about the cladding system. You can say the framing here, wall framing, inside wall, and then sheathing. You can add in the insulation. Also you can add in the rigid insulation outside. And then you can add in the clip system from here to here, and then this clip system holding the cement panel here and here. So that's why when you know about the assemblage, it is simply change the exterior cladding. You can do the brick, you can do the stone panel, you can do the terracotta, you can be the cement panel, or you can be the aluminum panel, right? So there are lots of different finishing type basically from this assemblage. The cement panel is the high density and durable material. It is the lots of color option and the lots of different texture available. So from this region, this is very good. The roof material and the wall material, and the very good weather resistant material as well. The next type is reinforced concrete material, which is reinforced concrete roof. The concrete roof is also available. The temporary formwork setup and the pour the concrete for the roof, you can see that they just temporal the formwork, and then just kind of making out the insulation and over that, and then pour the concrete here. If you want to having the one single massing design from wall to roof, you might consider about this option. You can see the construction image here. This is the making the formwork, and then you can then reinforce the rebar, and this is the insulation here, and then this is a structure part, and then over this reinforced rebar, and then making out the formwork, and then simply pour this concrete to making out this concrete roof. So you can just find that this concrete roof in the flat roof mostly, and also you can just making out this sloped roof as well. You can just see the insulation, and then this is the concrete roof section, and then inside you can see the finished ceiling here. So when you're considering about these types of a roof, you can getting these more monotonous foam and pure foam designing using this method here. So also when you're using the reinforced concrete roof system, it is a little bit different construction method. However, this one is the very interesting construction process. It is a Teshima Art Museum designed by the new Nishizawa, which is from the Sana. So how they actually making out of this kind of a concrete cell or concrete roof. So this is a very interesting kind of a construction process. From the inside, this is very poetic and the pure geometry. This kind of this concrete loop is very well communicate with the nature. So I just kind of bring the one video. This video is very well to show about the construction process and also understanding about how you can actually using the concrete loop for the design, and how you can also consider about the different construction method. I can just kind of briefly talk about this construction method. So when you're just making this form, this is earth, and then you actually mounted the earth, and then you're making the formwork, and then you pour the concrete here, okay? And then after curing the concrete, you simply remove the earth, and then after that you just can making out this negative space. Okay, so I think you better to understanding that this all process from this video. Okay, I think that is kind of our last slide show, and then I upload the lab assignment today, and then please checking out our lab on the canvas, and then please meet with Eric today. And if you have any question about the loop, please stay in the Zoom. We can talk. Of course, if you have any question and then you wanna meet individually or face to face, let me know. I can making the arrangement and making the appointment together. We can just talk together in a studio or in a school. Okay, so let's watch this video together, and then thank you so much for today.